السلام عليكم متابعيني خوشويست لواني او روماندا دزبا 7.3 دكين باشا which is about electrical current and resistance. يكم شد باس دكين باس electrical current دكين و it is relation to the charge movement باشا كاتا يكم شد باسي بكن definition electrical current يعني باب زانين current يا نتواني بلين current that is the rate at which electrical charges pass through a given area باشا and it is measured in ampere. ما بس ما لو شتيتي بابا تواني بلين اگر وايرك ما نبو باشا let's say this is the wire. How many electrical charges flow باشا through a given area at a certain time? You can call that electrical current. كاتا وكو equation بابا تواني بلين current باشا symbol كيتيا symbol كي آية باشا دكاتا تيا دكاتا بابلين when we say the rate of يعني something divided by time قاعد لي بابا هم تاري كدلين the rate of يعني something divided by the time that would be the rate of flow we can say باشا and then the rate of بابلين electrical charge movement باشا يعني تواني بلا electrical charges passing and flowing through a given area كاتا تواني بلا charge divided by the time that would be the current باشا كاتا how many charges flow باشا how many charges flow through a given area, which is the wire in this case here, Basha, in a specific time, in a certain time, you can call that what? You can call that one electrical current, Basha. Kata electrical current good symbol like and it is unit, yan bablin SI unity, SI unity, bablin current baba, SI unit okay, it is ampere, Basha. Ampere. Adi symbol ampere we'll use the letter A for ampere. What the 20 bulashi ampere later the kata sibaba. The kata unity charge is coulomb, unity time is second. Kata tonabelin ampere, it is equivalent to coulomb per second. Kata SI unity, current it is ampere, bazaga libi ampere, is also equal to yan bawlin equivalent to coulomb per second. Bazagar bisarat ogati SI unit, then ha ampere, baz ampere the kata dushta, agar libi kata tonabelin the rate of taban the 20 bashazi you can call that, or you can just simply use the equation to define current. You could say it is the rate of charge flow. Basha. The rate of charge flow and charge flow per unit time, that would be the current measured in ampere. According yan but the 20 from the equation you could clearly see that this current here, Basha, it is directly proportional to the charge. The more the charges flow, of course, that means the more the current, Basha. And we can see that the current, it is inversely proportional with the time. Basha, that are flowing. Flow the conductor hata we can say the current is higher. Agreement 5 charges flow, Basha, in two different wires here. Yekachan Babylon 5 charges is flowing here through a given wire, Basha. I will say Babylon 5 charges, Basha, but this one here, these charges flow in 5 seconds here. And should 5 charges flow, Basha, but these 5 charges flow in 1 second. Kata, in which one of them more current flow in a Babylon per unit time? Of course, flow that can in a given time it is more compared to other one. Compared to the other one. So 5 seconds, the 5 charge move the kakata to yak charge will move, like per second. But later the 5 charges flow, Basha, in every second. Kata, of course, the current in the second wire will be higher compared to this wire. Now, few study tips regarding electrical current. Basha, good money come shit. Electrical current it is equal to charge per unit time. Or come shit good man dom should the the SI unity current is good man it is ampere when ya agar libi ampere shit is equivalent to charge per second. Well khalisim the 20 blind again from the equation if you can see here man if we have a charge of Basha if we have a charge of 1 coulomb Basha that is passing and flowing through let's say per unit time in a time of 1 second, Aukati will get a current, Basha, that is 1 ampere. Kata, how can you define 1 ampere? We can say we get a volley and bablan 1 ampere when a charge of 1 coulomb is passing through a conductor at a time equal to 1 second. In order for the current to flow, Basha, and for the charges to flow, we need to have a battery or a power supply. So agreement, agar waraku light bulb it doesn't matter. Let's say this is a light bulb, Basha. Okay, but we have a light bulb here. If you have a wire and a light bulb here, but if you don't connect them to a battery or power supply, will this light bulb ever work? No. In order for the charges to flow حتى charge كان بتوان الناس سركتك بتوان move can and flow can, we need to have a power supply and a battery, because without a battery these charges cannot flow through a circuit. Once you have for example, a battery or power supply, now charges can flow through the circuit. Current will always flow from positive to negative, but electrons will always flow from negative to positive. Another point that is also worth mentioning is that later, if we have this is what is called the circuit. If the circuit is not fully connected, charges cannot flow. And again, if it is not fully connected, these two pieces of wires are not connected. This is the light bulb in here. And then this is the battery. Even if you have a battery, I can connect nibin. Do you think the charges will be able to flow and current will be able to flow through the circuit? Because it is not connected. For current to flow, the circuit must be closed, or we must have a closed path we connect them so that the current can flow through the circuit. Again, current natwani move kayan flow katin. This is what we have. Definition electrical current symbol. It is the rate at which the rate at which, and is something divided by time at which electrical charges pass through a given area. Delta Q, yan Q over time, that would be the current. Current is measured in ampere symbol. Equation I stands for the current, Q for the charge, T for the second. Okay, time for second measured in second. The SI unit for current is ampere. 1 ampere دكاتة بابا. أجر هاتو charge had بيك كولومبو in a time that is 1 second. The current that you will get, it will be 1 ampere. The direction of current, it is always from positive to negative. But the direction electron كان هم زاري negative له positive. These are important. We've mentioned that electrons cannot flow without a power supply. واركو light bulb كتبي if they are connected بابلين ببي battery أو بابلين light bulb كهيتيش دكان خارجنا كاتنسك you need a power supply, you need a battery. Once you connect a battery, now you can say the light bulb will work. That if you want the current to flow through the circuit, closed a closed loop we connect current cannot flow. For current to flow, there must be a closed circuit. Closed circuit can connect this is one of the things that we have later. Direction current is flowing from positive to negative, but direction electron it is always flowing from negative to positive. And you can call this one here. By the way, the direction of the current direction current, it is always the same as the direction of positive charge movement. Direction current opposite to the direction of electron flow. Positive flow, negative. The current in a light bulb is on the it is 0.835 ampere. How long? How long find delta time. How long does it take for a total charge of 1.67 coulomb to pass through the filament of the lamp. Q and delta Q over time. How long? Time command او دوی 20 swap K 20 بلين delta T دكاتة Q charge over current. charge divide كهرباء ليرة بينو سينو أو charge كاين بابلين هيتمان, it is 1.67 divided by the current that we have, it is 0.835 ampere. Once you divide the two, of course you'll get 2 seconds. So this is how long it take for 1.67 charges to flow, let's say to flow through the circuit. اگر current كي بونو عبي او نوتش من هي قال لي بابا ئەو نۆتە پێشترش کەندیتمان گوتمان هەر کاتێک داوای ژمارەی ئلکترۆنەکانی کردە و کاتی دەڵێن n which is the number of electrons ژمارەی ئلکترۆنەکان دەکاتە چێ دەکاتە the charge on the object divided by the charge of electron باشە بەس لێرە تەنها ماگنیتیودەکانمان دەکاتە توانێت بڵێ نەگەتیڤ و پۆزیتیڤەکان پێویست ناکات بیان نووسی پرسیارش دیکەمان هەیە چ دەڵێ پرسیارە it is very similar to what we had before پرسیارەکە لێرە دەڵێ if the current in a wire of a CD player is ئەوەندە باشە کەواتە 5 milliampere ئەگەر لەو ملیە how much is a milli we know that it's 10 to the power -3 وەنیە کەواتە توانێت بڵێن کەرەنتەکەمان هەیە it is 5 times 10 to the power -3 ampere باشە ئەو -3 ampere چی دیکەشمان هەیە پرسیارەکە دووبارە دەڵێ how long ینی delta timeەکەی ببینەوە باشە would it take for or it would take how long would it take for 2 coulomb of charge کەواتە ئەو چارجی کاتمان چەندە it is 2 coulomb of charge باشە to pass through a cross-sectional area of this wire دووبارە عینەن شدەکەی باب گوتمانی کوژنی کەرنتی دەکاتە چێ دەکاتە delta q یان q over time وەنیە we want delta time so you could swap this to here کەواتە دەڵێن delta t دەکاتە چێ دەکاتە charge over the current here chargeەکەمان 2 coulomb باشە 2 coulomb با بڵێن کەرنتەکەمان چەندە it is 5 times 10 to the power -3 لەبەر چ -3 چونکە دەڵێ milliampere باشە کەواتە once you divide it of course you get 400 seconds یانش دەتوانێت بنووسی 4 times 10 to the power +2 that's a positive okay now that would be second باشە that is the same as 400 that's about we لا بينه زۆر باشە کەواتە لا بین تەنها دەڵێن 4 times 10 to the power 2 that is going to be second پرسیارش دیکەمان هەیە ئەو پرسیارە تەبان پرسیارێکی زۆر مهم و جوانە دەڵێت in a particular television tube باشە in a particular television tube the beam current is ئەوەندە ئەگەر لێبی مایکرۆشمان هەیە مایکرۆ چەندە 10 to the power -6 ampere پرسیارەکە دەڵێ how long does it take for this much electrons to strike the screen here ئەو جارە بابە دەڵێت دڵتە تایمەکەی ببینەوە باشە بەس ئەو جارە چارجەکەی نەدای ژمارەی ئلکترۆنەکانی دای باشە so this is going to be the number of electron کاتە what is given you can write it down کەرنتەکەمان هەیە کەرنتەکە 60 micro ینی 60 times 10 to the power -6 ampere باشە گوتمان پرسیارەکە دەڵێت دڵتە t ببینەوە باشە و t دیکەشی داینێ n ژمارەی ئلکترۆنەکان باشە which is equal to 3.75 times 10 to the power +14 باشە یان دەتوانێت بڵێن 14 ئەوەش ئلکترۆنە وهێندە شت دەداتێت دەڵێ recall that an electron has a charge of -1.6 times 10 to the power -19 coulomb باشە ئەمە we're just going to solve this one the way that we used to solve گوتمان پێشترێ دەمانگوت کەرن دەکاتە چەند دەکاتە charge over time وەنیە زۆر باش پرسیارەکە دەڵێت تایمەکەی ببینەوە کەواتە delta t دەکاتە چەند دەکاتە charge that is flowing you can say divided by the current lira کەرنتەکەمان چەندە this is 60 micro 60 times 10 to the power -6 ampere باشە بەس لێرە چارجەکەمان نییە ئەگەر لێبی but what we have it is the number of electrons باشە کەواتە if I have the number of electrons how can I find the charge پێشتر ئەو یاسایەمان هەبوو دەمانگۆ n ژمارەی ئلکترۆنەکان دەکاتە چێ دەکاتە چارجی objectەکەی باشە on the object یان بابڵێن the charge is flowing divided by the charge of the electron ستا ئەمە we're going to cross multiply here because we want to find the number of charges here وەنیە کەواتە we're just going to multiply this to here کەواتە دەڵێن charge on the object and charge flowing دەکاتە ژمارەی ئلکترۆنەکان جارانی charge electron ژمارەی ئلکترۆنەکانمان چەندە it is 3.75 times 10 to the power 14 times charge electron چەندە بابە 1.6 times 10 to the power -19 ڕەنگە بڵێمەوە سادی ئەو نەگەتیڤە ئێرە بابە we just want to find the magnitude of the charge ینی پێویستمان بە نێگاتیڤ و بە پۆزیتیڤەکانی لێرە کەواتە تەنها چارجەکەمان دێتن لەو حاڵەتەی چارجەکە دەکاتە چەند گوتمان 3.75 times 10 to the power times 10 to the power 14 باشا أنا لابين قطمان multiply by the charge of the electron which is this much now استاك a charge object تكي دكاتا سن يعني بابلين charge is flowing أو كاتي دكاتا 6 times 10 to the power -5 coulomb of charge this is the charge that is flowing باشا استاك ورا charge كي بين ليري دابنيو you can find how long it takes باشا so now let's just write this one باشا كاتا we can say the charge that is flowing it is 6 times 10 to the power negative 5 coulomb divided by this. Now you can find the time which is going to be 1 second باشا 1 second. كاتا this is how long it takes. فكرة برسالة اللي تسوي بابا أما ليرة كرنتا كمان هي باشا بس شارج كمان نين لتزياتي شارج كي جماري إلكترون كان دريا ومش equation كمان هي هر كاتك جماري إلكترون كان دريا ويان داوا كرا we use this equation دلن n which is جماري إلكترون كان دكاتا charge on the object divided by the charge of the electron باشا ليرة جماري إلكترون كان من هي charge من هي كاتا just cross multiply to find the charge on the object and the charge that is flowing أو كاتي دبينيو كدي توري الإيكويشن كدابنيو والله ما كدبينيو زور باشا that is regarding this question here تيدي كشمانية بسارش مانية بسارش اللوحة كم دلي a total charge of 9 micro باشا micro coulomb micro تعرفوا ملي باشا ملي تسندليرة times 10 to the power negative 3 قلت ما نقر micro با negative 6 بو ملي negative 3 pass through a cross-sectional area باشا of a nichrome wire in 3.5 second here got the tone below delta take here بسارك يعني in the first part of a question دلي تبينو دلي what is the current in the wire باشا current in the wire قلت ما ليه توني قفنا كان بنو سجر حزليو قلت ما نشارج كذا كاتا 9 ملي negative 3 coulomb باشا time كمان it is 3.5 second ده باشا for part A here قلت ما part A دلت سبينو دلت current كيف بينو إيه باش current كذا كاتا دلن current كاتا يلا بابا charge over time ونيا زور باش charge كمان سندا قلت ما 9 times 10 to the power negative 3 لبروي ملية divided by the time which is 3.5 second. Once you do the math, of course, you're going to get 2.6 times 10 to the power negative 3 amperes. Oh, this one بلان والله مي بشيء كمان. Part B, what does part B saying? I got let part B be. دلت سبابة. How many electrons? قلت مان بشتري نوتا كي بشتري اللي بير ببابا. هر كاتا قوتي. جماري إلكترونا كان درابيان دا أكراو says how many electrons أو كاتا use the equation and the كاتا charge object إلى سر charge electronic زور باشا قلت ما ندلي how many electrons pass through the cross-sectional area in 10 second بابا أقلو time بيتنا ما قلت ما هر كاتا قلتي how many electron use the equation that we have باشا كاتا and the كاتا تي and the كاتا charge on the object and bubble and charge that is flowing divided by charge electronic أما charge electronic we already know that that is 1.6 times 10 to the power negative 19 ما بيز بنقت فكيناك ما ينسى باشا But later, what about the charge on the object here? I got Libby, charge كمان. You might say, so what about this charge here? I got Libby Baba. We cannot use this charge because this charge, right, can flow and can pass only in 3.5 second. Got in 3.5 second, this much charge would be flowing, Basha. But later, time كمان سنة 10 second. Basha. Of course, in 10 seconds, the more the time, the more the charges will flow. Kata, we cannot use the same charge over there. Let me charge it in Kata, according to this one, current mania, the kata say the kata charge flowing, Basha, divided by the time here. Salera current fix maybe because current tells you how many charges flow per unit time and bubble in every second. Basha, the 20 blend, current it tells you this many charge flow every second. What if we have 10 second, Baba? You could just multiply by 10 if you want to. Equation but man, we want to find the current and the charge for the charges here. Q the current times the time here. Basha, current kaman sanda, but man 2.6 times 10 to the power negative 3 ampere times time kaman sanda 10 second. Once you do this, of course, you can find the charge. 2.6 times 10 to the power negative 2 coulomb. This is how many charges can flow, Babylon Basha. Now, is that bring this charge and write it here. Charge, yan Babylon no charge flow deka in 10 second. The 2.6 times 10 to the power negative 2 coulomb divided by this much. Now you can find how many electrons will be flowing in 10 second, which is equal to 1.6 times 10 to the power 17 electrons, Basha. This is how many electrons would be flowing through that conductor in 10 seconds, Basha. This is what it is, Khali, see the, let's say, if the number, and part C, if the number of the charges that pass through the cross-sectional area during the given time interval is doubled, Basha. Is the agar jmari charge can, or charge on a بنا كوندكتركي دادرون اگر جماران double بكريتن كرنتك تسيلي. Of course the current would be double too ونيا باوي رشكينو باشا بتمان the charges because يعني had the 20 you can use this equation here. Blank current is directly proportional to the charges here. When yeah, I got charge a double because of course the current will be double too. When yeah, that is one easy method. I get هذه equation كي بكار بينا بتمان current دكاتة سبعة دكاتة charge over the time here. بس قال لي بضل charge double be at the same time. قال لي ببابا ضل باشا during باشا the given time interval يعني during the same time. غير بيشتري charge كمان سنبو بابا was 9 microcoulomb بوكاتي that one بلين دو زاران charge because it's double when yeah كاتا 2 times q 2 times 9 times 10 to the power negative 3 divided by 3.5 أوكاتي كرنت كده بيتا تسن بابا كرنت كده بيتا 5.1 times 10 to the power negative 3 ampere. هو ده شمان تواني أو كرنتي بيشتري تسنبو أو كرنتي بيشتري همان بو was 2.6 باشا times 10 to the power negative 3. هستا اگر charge که double بيتن of course كرنتي كش double بيتن كاتا دو زاران أو كرنتي كا بيشتري همان بو 2.6 times 10 to the power negative 3 أو كات you'll still get the same answer which is 5.1 times 10 to the power negative 3 ampere باشا. So whether you do this or even this one, these are all the same thing. بس ليرة of course because the question says what is the resulting current, that it would be better to do this part right here. And how much does it change? It is best to use the math, and do the math to answer this question right here. Conventional current is defined in terms of the positive charge movement. Once you connect قلت مان directionally current man here لقل directionally electron man here قلت مان the current it is always flowing from positive to negative when yeah but the electron كان قلت مان they're flowing from negative to positive استاكد توانين بلين بابا directionally current it is the we can say that it is the same as the direction of positive charge movement كاتا we can assume that positive charges move from positive to negative when yeah that would be the direction of the current even though we know that positive charges do not move in a conductor like in a metal here, but this is the reason why we call it conventional current, Baba, because previously scientists thought that current flow from positive to negative, but nowadays we know that it is from negative to positive because only electrons are moving. But because it came so long this way, so they'll just continue using that one. But when we say the current, like we always say the direction of the conventional current, like old convention, the old method, the old ways that old scientists assumed or believed to flow. Basha, بس ليرش تشواني بابا to just remember this. لخد مشي أنا قلت direction electron كان it is always from negative to positive. Direction proton كان positive to negative. يعني direction current كان it is bubbling from positive to negative. بو شوي لبيدي دي مشكلة نابي إن شاء الله. ليه ريك دوشت ماني قال لي بي توان بلين conventional current قلت man define as the flow of positive charges قال لي بي و charge carrier ذكري positive بيتني يعني negative بي باشا. بس قال لي بي لا conductor كان بابا يعني no metal كان it is only the charge carrier will only be the negative charges سكر بروتون كان ناتوانن move كان يعني بزولين. أحسي دي كشمانة توان بلين. In other cases, in gases or salts, both positive and negative charges move in opposite direction. أگر solution كمان أبو أوقات إذا كريه بلين charge carrier كان هم positive كان هم negative كان لناو solution كان move دبن أسايا. Good conductors allow charge carriers good man charge carriers to flow easily. when أما conductor man هي لقين insulator man good man conductors are materials that allow bubbling charges to move to flow easily, but insulators they do not allow the charges to flow easily. تسكا free electronia يعني زوزو كما زور باش body fluids and قلت ما metals are excellent conductors or بشتري باسيا ماكت body fluids and salt water. But the reason why قلت man body fluids and salt water, these are of course these are conductor too basha. And there is another reason that like sometimes we say if your hands are wet don't touch the sockets or outlet. Why? Because now it makes your body to be a better conductor. In that case, of course, you might have or you might get electrocuted or you might have a higher chance of getting electrocuted باشا. There are the 20 billion body fluids and salt water conduct electricity because they contain charged ions. They act as a charge carrier in solutions, we can say. It is called electrolyte باشا. It is a solute that dissolves in water باشا to form solutions that are capable of conducting electrical current. It is called the drift velocity باشا. Drift velocity we can say it is the net basha velocity of a charge carrier moving in an electrical field. What exactly does this mean here? So that if you have is that, for example, if you turn the light on in your room, let's say, or in your class, okay, the moment that you turn the light on, for example, the light comes on almost like instantly, right? So of course, the reason why you might think because electrons move kind of like almost at the speed of light. This is why the light comes on almost instantly, right? It is very, very fast. But that is not the reason why. The reason Baba Gutman, electrons, as a matter of fact, electrona كان زوزو خاون باشا أو إكوا مثلا the reason why Gutman سببي أو شتيك Gutman لايتك زور بخيراي بيدبي because electrons carry the charge and pass it on. For example, I'll get the energy باشا from the neighboring electron, then I'll pass it on to the one beside me, then to the one beside you basha. So this is how basha energy electron this is how it passes on basha. But indeed, like or as a matter of fact, electron can zozo conductor for example in copper wire basha, in order for electrons to move لو electron can يقمتر distance ببرن باشا يعني in order to move 1 meter they need 68 minutes باشا كاتا electron movement inside the metal is very very slow actually بس اوي كاودك بابلن charge زور بخيراي بقات لايتكو ايش كاتن that is the energy بابلن will be passed on باشا يعني دتواني بلي ريزنكا the change كهركاتك بابلن سويتسكت بيكر the electric field now conductor كده غورا this change in the electric field of course will be passed on very quickly until Gutman reaches the light bulb and it makes it work. Kata أوليرا energy كده غازيتو إلكترونيكية electron movement كان زوزو خاون لنا conductor كان بسوي كا بابلن charge كده غازيتو the electron pass on the energy rather than Gutman moving the energy with them. باشا كاتا شتش ديكش معناه resistance to current باش بابا Gutman شت دتواني بلين resistance resistance to current. Remember if you have a circuit, let's say, that has a battery, a wire and a lamp, the potential difference and of course the more the potential difference the more the electrical current will flow through the wire when you relation او دوی director كاتا potential difference كا تربيت نو current كا بنوارك دا دروات زياتر دبي كاتا we can say that potential difference باشا affects the current potential difference كا بمان ضلت current برواتن لنوارك يعني باش تشديك شيء كا it limits باشا controls the current flow and that is the resistance of the wire باشا كاتا وايركش resistance دتوان بلن وايرك resistance هي ما بس ما لويتي بالضبط بابا كدلن واير resistance هي ما قلت ما تازا باسو ما كد قلت ما حتى potential difference كزيادة بي current كزيادة دي بنيا but of course if we're using different wires that might affect how many charges can flow باشا so resistance now وايرك وذا كاتن or controls how much current to flow through the circuit here. باشا كاتا تواني بلان definition كمان هي resistance definition resistance about definition كيتسيا it is the opposition presented to the electrical current باشا by a material or a device. وكو equation بابا تواني بلان if we have a circuit باشا معنا قص circuit كمان هبو this is a battery this is the symbol of a resistance باشا and let's say this is positive side, negative side, Gutman current will flow, of course, from positive to negative. So this resistor limits how much current can flow through the wire and bubbling through the conductor. Basha. So this is a resistance here. So what is exactly this resistance here, Baba? We can say resistance that is the opposition that something that opposes the flow of current. Basha, the 20 billion resistance. Waku, what is it called? Waku fast statue. Consider we have a pipe, Basha. This pipe, of course, water flows through this pipe in here. Now we have a control, we could say, or what exactly do you call this one here? So this thing here controls how much water can flow through this pipe. That is exactly doing the same job as a resistor here, we could say. Kata resistors are devices and materials that limit how much current can flow through the wire. Basha, بكردك توان بلن resistance baba. Device كيان type wire كي material كي that controls basha the 20 control او current بكاتن يعني electron بكاكوا that is traveling and flowing through the wire basha. That is what is called resistance. What equation baba the 20 بلن resistance the kata potential difference divided by the current in here. Kata, you can see that the relation between the two is directly proportional, but these two are inversely proportional. Basha, kata current can subject to blend. It is directly proportional with potential difference, but it is inversely proportional with the resistance. The more the potential difference, the more the current is flowing. Basha, that is if the resistance is constant. Basha, for example, now if I use a battery that is 1.5 volt, if I use a battery that is 1.5 volt, it allows a certain amount of current to flow through the circuit. But if I increase, let's say the voltage, make it 3 volt or make it, let's say 6 volt or 9 volt or even 12 volt, for example, the more the potential difference, the more the current flow through the circuit. Because potential difference would be pushing the electron and giving the energy to the electron to flow through the circuit. But the thing that we have is the relation between the current and potential difference is directly proportional, but the relation between current and resistance, it is inversely proportional. What does that mean? That means the more the resistance, by the way, if the potential difference is constant, basha, and for a constant potential difference, I get potential difference bablin, delta V was 12 volt, basha, was fixed. لو حالتي اگر رستانسك زياد بيتن بابا كرنتك تسيلي دي كرنتك كم ده بيتن باشا ادي اگر رستانسك كم بيتن او كاتي كرنتك more current will flow through the circuit. Kata, the relation between the two is inversely proportional. Kata, according to this is that توانين بلن دو شد كنترولي كرنتي دكا يكا چان potential difference حتى potential difference كا زياتر بي كرنت چي زياتر بناو كندكتر كي واركي دا دروا. The second thing is the resistance. حتى resistance كا قلت مان قورتر بيتن كرنتك كم تريا يعني بعكسوا حتى resistance كا كم تر بيتن كرنتك زياتر دا بيتن that is flowing through the conductor here. Kata, one more time, Baba, the one below resistance, the kata delta V over current, that is called Ohm's law, by the way. This is something very important. You will need it this year and next year as well. This is called what? This is called Ohm's law. Basha? Ohm's law. Basha, the unit, Basha, and the SI unit for resistance, it is Ohm, Baba. Basha? What is it? Ohm, Basha. Symbol is omega, which is a Greek letter. Kata, we'll just still call this one Ohm, by the way. Basha, kata, the unit for resistance, it is Ohm. Basha, unity potential difference, you know that it is in volt, and the unit for current, it is ampere. Kata, 20 Ohm, Basha. Ohm, it is equivalent to what? Which is SI unit, obviously, for resistance, it is equivalent to volt over current. Once again, you will need this one for grade 12 as well. Labirid bi Basha. Kata, this is, now we can say the resistance of the wire, and the device, of course, limits the amount of current that is flowing through the circuit. It is the opposition presented to the electrical current by the material or the device here. The more the voltage, the more the current, but the more the resistance, the less the current. You could just look at this one for fun here. For example, the voltage is the one that is pushing basically the current or the electrons flow through the circuit, so that would be the current in here. But of course, the one that is limiting the amount or how much current can flow, that would be the resistance, Basha, which is clearly limiting how much current can flow. Of course, we can say that agar potential difference ka 1 volt between current ka 1 ampere bi awqat resistance ka debita san debita 1 ampere. Shta shudi kaman he lere baba. We have two type of material that is called ohmic and non-ohmic material. Ohmic material ma bas mansiya او bablan device and bablan material that follow Ohm's law basha. They follow Ohm's law. But only the non-ohmic they don't follow Ohm's law. Ma bas ma lo yisi baba. Current voltage is a straight line, huh? But man, I get temperature. I can go around babbling. If the temperature is fixed, no matter how much you increase or decrease the voltage and the current, the resistance is always the same. It's fixed. It doesn't change. Basha, as long as the temperature is constant. But non-ohmic, all right, different voltage or different currents, of course, the resistance will change. يعني بابلين when the voltage is small, there is a certain resistance. When the voltage increase, the resistance will change, باشا. But this one, whether you increase or decrease the voltage, as long as the temperature is the same, the resistance will always stay the same, باشا. Good man. That would be we can say the main difference between the two, باشا. Dalan constant resistance at a given temperature بس ليه resistance vary and change with voltage or when the voltage or current change. Well, good man, these are for metals like copper, aluminum, and resistors. These are for, you could say, semiconductors, diode, transistor, and semiconductors in most. And the Tony Blaine away card is also going to Tony Blaine Baba Khali Kamu, Khali, the Tony Blaine Samu. Tony Blaine the diagram here, because that would be point number 2 is the diagram. Then follow Ohm's law. This one doesn't. This is a straight line. This is not a straight line. Good man, this is constant if the temperature is constant, whether the voltage increase or decrease, but this one is not constant. It can change by changing the voltage and the current here. Zor Basha, the resistance depends on the length, area, material, and temperature. There are 4 factors that affect the resistance of the material. Basha, what are these 4 factors here? We're going to mention them, Basha. So the first thing, if you want to know that there is an equation to help you understand better, good man, those factors that affect, Basha, Basha, that affect what? That affect the resistance. Basha, of course, you can write this equation to help you remember them. We could say resistance, that is equal to resistivity. We used to, by the way, this is not P, Baba. Of course, we use this symbol for different purposes, depends on where you use them. At one point, we used to use this one for density, but it's stuff for resistivity. Resistivity times length divided by the cross-sectional area. What exactly are those factors that affect the resistance now? The first thing that we have, of course, according to this, you can see that is the length of the wire. Basha? The length of what? The length of the wire. What exactly do we mean by that? Basha, we have 2 wires, let's say, Basha. These 2 wires, we must have the same, by the way. Let's just, we must have the same cross-sectional area, the same type of wire, Basha, but of different length, Basha. So once, for example, now, we have 2 wires. One of them is longer than the other wire, even though they have the same cross-sectional area. According to the first rule here, we can say that resistance is directly proportional to the length of the material. You can call this one L1 and call this one L2 here. Basha? The longer the length for the same material, Basha, the more the resistance. The 4 factors that affect the resistance are, Basha, Gutman, the first one, we could say the length of a wire. That once again, حتى درجي وارك زيادة بيتن resistance زیاتر دەبی ئەوە یەکەم خاڵی دوم دەتوانین بڵێن ئەو شتانەی کە ئەفێکتە resistance دەکەن it is the cross-sectional area. مەبەستمان لە cross-sectional area چییە؟ Let's erase this too. Just in case باشە. نەحوەش لابین. خاڵی دەتوانین بڵێن دووەم it is the cross-sectional area. Cross-sectional area. Cross-sectional area. What do I mean by this? Now imagine if you have 2 wires, Basha. Well, one of them has a larger cross-sectional area compared to the other one here. And of course, I think you can see the difference between the two. And yeah, cross-sectional area. The bigger the cross-sectional area, the less the resistance. Basha. Relation between resistance to cross-sectional area, it is inversely proportional. Hata واركة thickness كي زيادة بيتن دتوان بلن resistance كي زیاتر هاد واری بابلن بویلر و اوون و هیتر و شتان عادتن وارکانن استوره لبرته چونکە بابلن رستانسکی کەمترە هەتا گەرم دانێت و یان بابلن تووشی شۆرتی کارەبایی نەبیتن باشە ئەوە دەتوان بڵێن خاڵی دووەم خاڵی سێم it is the type of the material یانش دەتوانین بڵێن resistivity باشە type of the material باشە material and you can call that resistivity باشە يعني resistivity ما بس نانسي بابا هر material resistance تایبەتی خۆی. For example, some materials are better conductor than others. وانیا کەواتە توانین بڵێن هەتا مەتریالەکە باشتر کۆندەکتەر بیتن زیاتر resistivity کەمترە یان resistance کەمترە باوا بڵێن باشە. For example, now we have iron and copper. Which one is a better conductor? Of course, copper is better conductor. کەواتە توانین بڵێن resistivity کەپەری کەمترە بەمعنای چ دیکە ئایرۆنەکە resistance زیاترە. Of course, there would be more resistance to that. The third one, we can say the type of the material or the resistivity. The more the resistivity, the more the resistance. You could think of it this way, the more the resistance here. And then the fourth one here, which is not in the equation, we can say the temperature. How is the relation? This is very important. How is the relation between temperature and resistance? Baba, hata temperature زیاتر بیتن resistance که زیاتر دبی لبرچه. Because when the temperature increases, the particles vibrate more inside the conductor. When yeah, electronmechanics they're trying to pass through. Kata these particles are vibrating, and you're trying to pass through. Of course, these will collide. Kata electrons cannot make it to the other end, cannot flow easily. The resistance که زیاد دبی. And بکرتیا که نتوانی بلین the larger. The bigger the temperature, the larger the temperature, the more the temperature, the more the resistance. These four factors affect the resistance. There are 6 factors in the equation that temperature is. Those 4 factors affect the resistance of the material. Cross-sectional area. وارەکە cross-sectional area گچکەتر بیتن resistance زیاتر دەبێت یانیش دەتوانی بە نوعی دیکە بڵێ هەتا cross-sectional area گەورەتر بیتن resistance کەمتر دەبێتەوە because they are inversely proportional. خاڵی سێم گوتمان material type materialەکان resistivity, the better the conductor, the less the resistance. باشە خاڵی چهارەمیش گوتمان temperature, the more the higher the temperature, the more the resistance. باشە ئەگەر لە چهار خاڵە بی ئەو چهار خاڵە زۆر گرنگن. زۆر باش. با بڕۆینە یەک دوو پرسیاران. پرسیارێکیان دەڵێ how does the temperature affect the resistance of most of the material? باشە تازە باسمان کرد گوتمان هەتا temperature زیاتر بیتن resistance لەگەڵەوەی زیاد دەبێت because these two increase together. کەواتە you can say the higher the temperature, the more the resistance. لەبەرچێ because increasing the temperature makes the particle to vibrate faster. More vibration means more collision, more let's say electron bumping into atoms bubbling of the material lose their energy. Resistance زیاتر دەبێت دەتوانێت بە نوعی یان بابڵێن less electron flow. باشە electron یان دەتوانێت بڵێن resistance increases with temperature because harder materials have faster atomic vibration, making it harder for electrons to flow. باشە لێرە یەک دوو خاڵی دیکەمان هەیە ئەگەر لێ بخراب نییە دەڵێن in many circuits بان بابڵێن household potential difference of voltage remains the same. بە voltageێکە ئەمە هەیتوان voltageەکە دەبی بە جێگیری بمینێتەوە because otherwise it might damage electrical device. ئەگەر ناڕەنگە جیازە کارەبایەکان بسووتێ ئەگەر voltageەکەی بەردەوام زیاد و کەم کاتن چکە باش نییان زیان بە ئامێرەکان دەگەێنی. باشە خەڵی دومیان دەتوانن بڵێن to change the current in a conductor. باشە لۆی بتوانین کەرنتەکە لە ناو کەندەکتەرەکەی یان لە ناو electrical deviceەکەی زیاد و کەم بکەین بەبێ ئەوەی voltageەکەی بگۆڕن چکە گوتمان voltageەکە جێگیرە. باشە کاتە we'll have to use resistors. We can use resistors to limit how much current can flow into the device without needing to change the potential difference. Gutman, this method is more it is more practical than changing the potential difference. Potential difference this is how much it is generated, how much sent to the house to the household. لگۆڕانەکەی زۆر ئاسان و عملینیە باشتر وایە resistance چی یان resistor بەکاربێن هەتا بتوانین ئەو کەرنتەی زیاد و کەم بکەین. For example, باڵێن تیڤێک لە ماڵی هەیەن ئەو لاپتۆپەی باڵێن بەردەست uses a certain amount of current. وانە کو بتوانین how can we control how much current to control how much current to flow through the device? We'll have to use it is best to use a resistor. باشە پرسیارشنی کەمانەیە دەڵێ how can the current in a wire be changed if the potential difference remain constant? ئەگەر بتمان voltageەکە remain constant بیتن how can we change the current? بتمان دەتوانین resistance یان باڵێن resistorێکی بینین. That resistor of course limit yan controls the amount of current that can flow through the device. باشە چکە گوتمان relationi بینیانە کووە relationەکانە that is inversely proportional. کاتە current دەکاتە delta V over resistance وانە if this is constant کاتە if this is constant Batman, what it can control the current is the resistor. By increasing this, the current will decrease. Agar away decrease can current increase the bikata. This of course inversely proportional. يعني تواني بلن resistor كده تواني control current كده زور باش. The current can be changed by using a resistor to adjust the resistance of the circuit. As resistance is inversely affects the current, and of course that is Ohm's law. زور باش عندك بسارة ديك حلقين regarding this. بسارك من هذا the resistance of a steam iron is 38 ohms باشا or resistance كده. Basha, what is the current? Current ببينه Basha, when it is connected across a potential difference of 220 volt. Got at this delta V. اللي بيدبو تesta بابا دو equation ماني له current. يك عشان current قد ما عندك هذا Q over delta T. ويدي كان delta V over R. Basha, it is one of these two equations. Which one do you think? شان بتوا شاني بكاربين نستعلي equation هي كم؟ يعني equation يدون. تو شو بسارك كبابا. أجر charge time تبغى use the first one. أجر potential difference or resistance تبغى use the second one. استأشي مانيا resistance and potential difference مانيا كواتا we can use the second equation مانيا. زور باش كواتا تواني بلين. If we start from this equation here, the تواني بلين delta V over current مانيا. إذا ما ليرة شيء ما عندي من current كم عندي كواتا you could swap this to here. The تواني بلين current دكاتة delta V over R باشا delta V كمان سنة that is 220 resistance كمان 38 كاتا once you divide the two of course you'll get 5.79 ampere خذ شلون زور عسى بلاي 5.8 ampere أو شان ذكري باشا كاتا this is the answer for the first question طبعا بسارة كان يوبشان بابا زور عسان همي بيستي بستيبك أو بريدو ستيبا هيتسي دي كينيا بسارش دي كمان هي potential difference كمان 1.5 volta باشا says battery connected to a small light bulb with a resistance كمان on there. What is the current in the bulb? زور باش توان نخطانا بنسيو delta V دكاته 1.5 volt وريستانس كشمان it is 3.5 ohm current كيت سنة زور باش استا current كقلت مان دكاته سنة current دكاته delta V over R ونيا زور باش current كدوبارة delta V كمان سنة it is 1.5 Resistance كمان it is 3.5. Once you divide the two, of course, you'll get 0.43 amperes. هون دي تدا هي سيدي كي تدانه. أبسارة شان سنة عينا وكوان ديك هذا له current كي ببينا. درشان current مان هي resistance مان هي له potential difference كي ببينا. باليرا بسارة شدوا حال كنت كده له potential difference كي. أو قلنا resistance يعني بابلين هرشان شدنا نسي قرينية. So let's write the given information first. Okay, the current in a microwave is 6.25 ampere. The resistance of the oven's, let's say, circuitry is 17.6 ohm. Let's say the potential difference. Potential difference يعني شبابا يعني delta V. زور باش. تواني بلين resistance ohm's law دكاتة سي delta V over I. باشا. است cross multiply كا. delta V لقلوانا delta V يعني potential difference دكاتة current times resistance زور باش current كمان سندا 6.25 resistance كمان 17.6 باش كاتا فولت جقد بيتا 110 volt واش والله مي بساري I believe these are super easy ونيا زور باش بسارش معنا سانا current معناها voltage معناها دلار resistance كي ببينو دكاتة اشتاهشتهم يكد say that. Salt water and perspiration lower the body's resistance. ماشا بشتري بس يوم كدو من بابا if your body is wet بابلن دستو بنزو بابلن نوان تربو يعني شنك تربو بابلن the outlet switch black تربو try not to touch that. Why? Because these bubble the whether if it is water or let's say perspiration these are did I say right? Yes. Perspiration, let's say, these are makes your body to be a better conductor. For example, normally your hand is a conductor too, but if it is wet, it becomes a better conductor. The risk of you getting electrocuted now, once your hands and body is wet, it is way more higher than once it is dry. Try not to get close to any sockets once the floor is wet or the socket is wet. Or if your body is wet, because this is not safe. Basha. Salt water can also lower body's resistance. Calcium makes it a better conductor. It is not safe. Basha. perspiration, which contains ions, also reduce body's resistance. One is called galvanic skin response test. What are these, Baba? Sometimes these are used for stress or lie detection. Whether he's lying or not, they'll use this device. What does this device do, Baba? You can say that it decreases and measures the resistance of the person. By knowing that, of course, they know whether he's stressed or not, or he's telling the truth or not. Basha. Here, potentiometers have a variable resistance. Potentiometer, these are devices that you could say divide the potential difference. You could say these are variable resistors here, Basha. We have resistors that have a fixed value, while they cannot goran carry this, but this goran carry liebkain, Basha. But we also have other Babylon resistors that we can change it as value. Those you could call potentiometer, Basha. Basha. For example, like what, Baba? You can call these are something, Basha. It could be having or turning something. It could be like something that you could turn. Sometimes we call it a knob. Baba. الراديو ساري Babylon وكتشي هي نوبتشي and Babylon this the volume button you could say, Basha. You could turn to let's say you could turn that clockwise, Basha. It doesn't matter which way you turn. You could turn it out, for example, the sound gets louder. What exactly does it do, Baba? Once you do that, for example, that lowers the resistance of the circuit. Now we could say more current flows through the speaker, the amplifier and speaker. Now you can hear a louder sound. What happens when you turn the other way around once you make it quieter? Now it's that once you turn the other way around, Baba, there be less current flow through the amplifier and the speaker, so of course now it sounds quieter. This is something you can call potentiometer. That is what's called potentiometer. You can make it, let's say, brighter, Basha, or you can make it dimmer. So you can control the brightness of the light bulb. That also, where these kind of like devices have also potentiometer variable resistors too, Basha. This is what you can do. These are how it looks like. This is kind of like in reality what it looks like. قلت ما نقدر قلوبك كتبوا دتواني دسكاري برايتنس كيف كي زادوا كم يبكي أو كنت جازي and device كا دتواني control brightness كيف كا. You can call that potentiometer. How do بزانم ECD كت بيوزني. Here on a section review بابا can the direction of the conventional current ever be opposite to the direction of charge movement? Bala. Let's get قلت ما direction current كي it is always opposite دتواني بلين to the direction of electrical charges. When especially we're talking about conductors though. When man direction current هم جاره it is directions opposite to the direction of electrons. Kata dekri direction current opposite the direction charge movement can be. Basha. But man, yes, conventional current it is opposite to the electron flow and negative charges. The charge that passed through a filament of a certain light bulb in 5 seconds is on the Basha. Delta T man here. There charge come on here. What is the current in the light? Good man, the equation man here current baba. Good man, I get charge you time okay dabu. Use the first one. When you current the cat say the charge over time. Charge come on sanda. It is 3 coulomb time come on 5 kata the beta 0.6 ampere. Oh khali dom delay. How many electrons baba is also getting a pass through the filament of a light bulb in a time interval equal to 1 minute. I got leaving 1 minute. Basha. لا يك minute how many electrons would flow, Basha? زور Basha. Good man, now how many electrons? Write the equation, the one that you know. Good man, جماري electronic number of electron دكاتا charge an object, Basha, divided by charge electronic. Okay, now staka, of course, charge electronic is 1.6 times 10 to the power negative 19. Yeah? But what about the charge of the object? Once again, we don't have that. So you'll have to find out how many charges can flow in 1 minute. Basha قلت currently equation كده كتسمو قلت ما عندك charge over time. Basha charge كده كده current times the time. ونيا زور باش current كمان تسمو in the previous question. Let's go back to this one. What was it? 0. What? Think we were 0.6. I have it. يلا بقى قلت مان n دكاتة current دكاتة, charge an object over the time, باشا. So now we want the charge, Q دكاتة, current times delta T, ما 0.6 times time كمان سند 1 minute يعني 60 second ماذا دكاتة سن charge it is equal to 36 coulombs باشا coulombs of charges تا ورا equation كي بكاربينو قلت مان ليرة n مان دكاتة 36 charge electronic 1.6 times 10 to the power negative 19. Then of course we can say 2.25 times 10 to the power 20. This is how many electrons will flow in a time that is equal to 1 minute. بسعرش معنى ضلي how much current would a 10.2 ohm toaster oven draw when connected to 220 volt outlet. طبعا ليه ضلي current كيف بينو current دكاتة سن دكاتة delta V over R, just like plug in the numbers and then you will find the answer to this question. بسعرش دي كش مان هي وش current مان هي voltage مان هي طلعوا السانس كيف بينو أبزا موشان زور آسان. بسعري بينزم ضلي what is the function of a resistor in a circuit board باشا ضلي إيشي رزستري يعني إيشي رزستانسيتية ل رزستريتية بابلين للسيركتي باشا قلت مان resistors limit how much current can flow when يعني simply limits the current flow. That would be a simple answer to this question. Now resistors limit current flow and divide voltage to protect components and control circuit operation. Knowing that resistors limit the current flow would be enough at this point here. بساش ديكش معنى delay يعني بابلين آخر بسال delay you have only one type of wire. If you're connecting a battery to a light bulb with this wire, how could you decrease the current in a wire? One thing that limits the current was the resistor. When you have only one type of wire, there is only one battery, you cannot change the potential difference as well. Delta V over resistance. Voltage is the battery, you cannot change that constanta basha. وجوري wire that is also fixed, you cannot change that basha. How can you let's say how can you change the current that is flowing through the circuit here? We could change the current, of course, by changing the resistance. But how can you change the resistor, Baba? Because now, of course, if we're going to, how about if we're going to, for example, there's no resistor at this point here to use, but later, because we're using a wire, Baba, of course, how about if we use a longer wire? معناتها دريجي wire كي جورة تربيت من رسانسة كتيلة دي زيادة طبعا أجر رسانسة جديد كاتن ماشا كاتا كرنتا كتيلة دي كرنتا كم دبي يعني جدتواني أذا بسارك طلع how could you decrease the current in a wire باشا كودة تواني كرنتا كي كم كانوا يعني سون تواني كرنتا كي كم كانوا قلت ما أجر رسانسة زياد بيت من كرنتا كي كم دبي how can you increase the resistance by increasing the length باشا because the length and the resistance are directly proportional. درجة كزياد كرستان زيادة برستان زياد ككرنتك كم دبيتها. باش. Got I use a longer piece of the same wire. باش. A longer wire has more resistance, which of course decreases the current, and that would be Ohm's law, or according to Ohm's law, because current it is equal to potential difference over the resistor. That would be the end of our session, inshallah. Next time we'll talk about our electrical potential. Till then, watan nagal.